The movie scene I chose was from Dodgeball, a True Underdog Story, and as you can see, they are playing dodgeball. He gets hit in the face, and he gets knocked back really far, and everyone's celebrating. But my hypothesis is that's not even possible. No way. Now we get into the measurements. The center line, it is 1 block. I measured all the tiles on the dodgeball court, and from the center all the way to the end is 34 tiles on both sides, and from the center to the little line of the logo is 32 tiles, and from the center to the bottom of the triangle it is 8 tiles, and we use these later when we calculate the distances. So the length of a dodgeball court is 18 meters because the ADA isn't a real dodgeball league, so I just went with the closest thing I could find. So then I did 34 plus 34 tiles plus 1 tile, and I got 69 tiles. So I divided 18 by 69, and I got 0.261 meters per 1 tile. Now, I did velocity equals distance over time as my first equation, and then time is equal to 1.27 seconds from the second the ball released from his hand to the second it hit his face, and the distance from triangle to triangle is 17 tiles. So 17 times 0.261 is 4.437 meters. And so the velocity is 4.437 meters divided by 1.27 seconds, which is equal to 3.494 meters a second. Okay, the next equation I used is acceleration is equal to velocity over time. So velocity is equal to 3.494 meters a second, and time is still equal to 1.27 seconds. So we put them over each other, and we get acceleration is equal to 2.751 meters a second squared. Now, we're going to use distance is equal to initial velocity multiplied by time plus 1/2 acceleration multiplied by time squared. And then we get rid of an initial velocity multiplied by time because it is 0. So then we define acceleration is equal to 2.751 meters a second squared. Time is equal to 1.27 seconds. Then we plug them in, and we get 1/2 multiplied by 2.751 meters a second squared multiplied by 1.27 seconds squared is equal to an acceleration of 2.219 meters. Now I'm going to be finding the distance that he traveled in the movie. To do this, I'm going to subtract 32 tiles minus 8 tiles so that I see how far he traveled from the diamond to the logo. So 24 times 0.261 meters is a distance of 6.264 meters. Now I will be calculating the velocity that the ball had to be traveling in the movie. So I do 6.264 meters is equal to 1/2 x times 1.27 squared, and I multiply 2 by 6.264, then I divide 12.528 by 1.27 squared, then I get 7.767 meters a second squared, then I multiply that by 1.27 seconds, and I get 9.865 meters a second. Now I'm going to convert it to miles per hour, so I multiply 9.865 meters a second by 2.237 miles per hour, and then I get 22.07 miles per hour. Now I'm going to convert the original velocity of the ball into miles per hour, and so I'm going to do 3.494 meters a second multiplied by 2.237 miles per hour, and I get 7.82 miles per hour. Now I'm going to calculate the distance into feet instead of meters. So I do 2.219 meters multiplied by 3.281 feet, and I get 7.28 feet for the calculated. And now for the movie, so I'm going to do 6.264 meters multiplied by 3.281, and I'm going to get an answer of 20.55 feet. And those are all my calculations in miles per hour and feet. My conclusion is that it was not possible, and that agrees with my hypothesis. After finding the velocity of the ball, the time that it took to travel, the displacement of the man after getting hit by the ball, it all proved my hypothesis correct. And that's the end.